welcome to another edition of Easy Theory. So what we're going to do here is slightly different from what we've been doing before, in that we're going to do multiple examples of this particular topic, which is the NFA to regex construction that we did in the last video. So remember what we did was we did a bunch of ripping states out of a NFA that we massaged a little bit for things to work, and after doing that, after a long period of time, we're going to have two states at the very end with a single regex on them, and therefore that will be the equivalent regex. So what I'm going to do in this first example is a really simple example, and I'm going to make it up right now. I don't have this example cooked up or anything. I'm going to make it completely up on the spot. So I'm going to have a 3-state machine, because if it was 2 states, then that would be almost too simple. So let's make it 3 states. So let's have, and we should have at least one state being final, because the regex would be really simple if there were no final states. So I'm just going to make one up right here. Let's just say it only has A and B on the transitions. So this one, let's say, loops on B. This one comes down on A and B. This one loops on A and comes back to here on A. Okay, so this is just a simple example. I just made it up. And now let's try to convert this to a regex. Well, this happens to be a DFA, but DFAs are already NFAs, so that's not an issue. So, and there's no epsilon transitions, although that doesn't really complicate things either. So remember, the first part of the construction is to add that new start state and the single final state. Well, you may note, okay, there's a single final state right here, so why do you need a whole new final state? The reason is we need a final state without any transitions leaving it, but this one does have something leaving it. So what I'm going to do is I'm going to make in orange a new start state. I'm going to call S, which has an epsilon transition to the old start state, and make Q1 not final, and it has an epsilon transition to a final state that I'm going to call F. Okay, so then now all that we need to do is to rip each one of the white states right here. I can't rip S, because then what will the start state be? If it was Q0 again, then we're back to the original problem. If I ripped F, well, then there's no final states left. So I better rip only the white states here. And you may notice that in the proof we didn't actually pick which state to actually rip. We just said rip any state that you want. And it turns out, yeah, you can rip any state that you want. So here, let's just pick any state. The order does not matter in terms of getting a regex that works. However, if you pick the states in a different order, you may get a different regex, but it just may look different, but it will be equivalent if you rip everything correctly. So let's just try to rip any random state. I'm just going to pick a random state here. Let's just rip Q2. This is not the state that I would actually pick, but I'm just picking this purely for demonstration purposes. So let's rip Q2. So I'm going to copy this whole machine down. So copy, and you may remember in the proof that we added all of the missing transitions. So like from Q1 to Q0, because there's no transition here, we would add a transition labeled empty set. I'm not going to do that here purely for making this look readable, but for correctness, you can actually do that, or if you wanted to implement it. Okay, so here I want to rip Q2 out. So now we got to look at all of the states that go into Q2, or what was Q2, and all of the states that Q2 goes to. And we see that there's a self loop on Q2, so we do have to take that into account. Okay, well, the states that go into Q2 are Q1 and Q0. So what I'm going to do is I'm going to make an in list and an out list. The in list is going to be all of the states that go into Q2, and out is going to be all the states that Q2 goes to. So, and not including itself. So the states that go into Q2 are Q0 and Q1. And what are the states that Q2 goes out to? Well, it's only Q0 in this case. So why do we make these lists? We make them so that we will handle all of the pairs of transitions that we need to add. So what we need to do is to pick one of those states in the in list and one state in the out list, and then add a transition for that pair. And then process the next pair, etc. until we are completely done. So here, let's just handle, maybe not that green, let's handle Q0 to itself. So what we need to ask is, how did Q0 go into Q2, which is this B transition right here, which is fine. Did Q2 have a self loop? Yes, it does, which is A. And how did Q2 go back to Q0? Well, it went back to Q0 on this A transition. So from the examples that we've done before, the resulting transition will be B, which is going into Q2, A star, because we can take this loop as many times as we want, or 0, and then going back to Q0 because that's the pair that we are considering right now. So that means that in addition to this self-loop transition right here, we're going to add a transition. So B was what the transition was before, but now we're going to union it with the transition we're adding, because you can either take the B route or you can take this more complicated route, which is going to be B A star A. So that's what we're going to put here, B A star A. And you may be thinking, okay, yeah, you can put A plus for this. I'm just going to do this as A star A because that's highlighting A is what was on the self loop, and then A was what came back. But you could abbreviate that if you wanted to. Okay, so then now let's actually handle the Q1 to Q0 transition. So here, we need to figure out, how did Q1 go into Q2? Well, it had A comma B. Well, what is that? That's A union B. So A union B is how we got into Q2. So what are we going to actually do here? So A union B was what came in, and we had A star for the self loop just like before. But now we're going back to Q0. So that means we're going to have a transition of the type A right here. So then that means we need to add a transition from Q1 into Q0, which is going to be the transition we're trying to add. Well, what is that going to be? Well, I don't need this B or this A transition anymore because they're not going to exist. So we had A union B here, A star here, and then A here. So the whole transition that's going to come backwards to Q0 is going to be A union B, whole thing in parentheses, because it turns out you have to have parentheses here, A star, and then A after that. You need to have parentheses around the A union B because of how precedence works with unions and concatenations, but either way. So here I'm going to have a transition here. I'm going to add it because there wasn't one before. And then the transition is going to be A union B, A star A. Because this is what the transition took from Q1 into the state we're taking out. A star for the self loop, and then this final A, which is the same as this A because it went back to the same state, Q0. Okay, so then now we have a simpler machine. Again, I'm going to copy it and then paste it below. And if you have any questions, please put them in the comments so that I can actually answer them. So now we got to rip another state. Again, we can pick any one of the two states. It doesn't actually matter which one we pick. So let's pick Q1. I just pick it randomly. It doesn't actually matter which one I pick. So again, we got to have our in and out list. So what states go into Q1 from somewhere else? Well, the only one is Q0. And where does Q1 actually go to? Well, Q1 actually goes to Q0, so that's going to go on the out list. And Q1 also goes to the F state right here, so I got to add that as well. So let's have the Q0 to itself transition. Maybe not in, actually in green is fine. So here we're asking, we're going from Q0 into the state we're ripping, which is Q1 here. And there's no self loop here, so we don't have to have any stars or anything, which is nice. And then from Q1 back to Q0 because that's the pair we're considering. So what is this going to look like? Well, it's going to be A, because that's how we get there. No self loop, so nothing to consider there. And then how do we come back? Well, it's this big boy right here. So there's already a self loop right here because that's the start and the destination state. So here I'm going to union it with whatever this is going to make right here. So that's going to be A, because that's what this part is right here, the outgoing transition. No self loop, and then concatenate with what takes us back, which is A union B, A star A. So you can actually start to see why it's nice for a computer to actually do this, because the regexes themselves get really, really long, but either way. Okay, well then how do we handle the other pair right here? Let's do it in orange. So how do we go from Q0 to F? Well, we go from Q0 into Q1 and then to F. So that's A, no self loop here, so that's nothing. And then an epsilon on this transition. So in total, we just have A, and that's it, because there's no self loop and it's just the empty string on the end. And when you concatenate with the empty string, you don't change anything. So in totality, we can actually get rid of this and have just a really long transition with just A on it. It's funny how this really tiny transition has a long name on it, and this long transition has a little name on it, but either way. So now we can actually rip the only state that we can rip, which is Q0, and it's pretty clear what's going to happen here, which is there's only one state coming in, one state that it goes to, and so the whole actual GNFA at the end is going to have a really long transition, appropriately long. And what is it going to be? Well, empty string takes us into Q0. Actually, I guess that's cut off. My face cut it off. So then, what is this going to look like? Well, it's going to be the empty string concatenated with this thing, whole thing star, the whole thing star, which is actually pretty big. It's so big that I'm going to actually copy it down. There's something that I also advocate here, but I'll probably talk about that in the next example that I do. So here is going to be the whole thing star, and then finally we have this A left, which takes us to F. So a final A. So therefore, the final regex for this this choice of ripping states in this particular order happens to be B union B A star A union A union B A star A whole thing star A. So even this really tiny example actually makes the regex quite big. But I hope this was actually relatively straightforward to go through. Put into the comments if you've found a different way of ripping the states out, a different order, that ended up with a much smaller regex, because oftentimes it actually does. So I hope that was interesting. Please like and subscribe to the channel. Check all the links out in the video description. It really helps us out. And as always, I'll see you next time.